Hello students, let us proceed with the topic current electricity which we were discussing yesterday. Now let's go ahead. The next topic, let us discuss Ohm's law. Already I have studied in class 10th. What is Ohm's law? Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor provided the temperature remains constant. That is, V is directly proportional to I or V equal to Ri, where R is a constant known as resistance of the conductor. So this we have studied in class 10th, and if you plot a graph for potential difference and current, then you get a straight line I and V. This is for ohmic conductors, means those substances which obey Ohm's law, and especially it is for metals. Now, if I talk about non-ohmic conductors, then what will you say? Non-ohmic means if you plot a graph, then you will get a curve like this. The conductors which do not obey Ohm's law means they are exceptions. So they are known as non-ohmic conductors. For those conductors, the VI graph is not a straight line, it is a curve. For such substances, you can find dynamic resistance. Dynamic resistance is given by a small change in potential delta V upon delta I. You can take any 2 points on the graph and you find the values of current and potential. So this will give you a change in potential and change in current for small part of the conductor. So this will give you a dynamic resistance. So this is for non-ohmic conductors. So I hope this is clear. Small topics. Then if I talk about specific resistance, or we say the resistivity, suppose, then you can write specific resistance or resistivity as the ratio of electric field to the current density. Or in terms of vectors, you can write this is rho into vector J. Now, you see this formula for rho. Since E equal to V upon L, this you know already, and J equal to I upon A, this is current density which we have already discussed yesterday. So therefore, what is rho now? This is V upon L upon I upon A. So this is, you write like this, V upon I into A upon L. You can see this now. What is V upon I? This is resistance. So rho equal to Ra upon L. This is the formula for resistivity. You might be aware of this formula. And also you can say R equal to rho L upon A. Definitely you know this formula. In 10th also you have studied. So rho is known as the resistivity of the material of the conductor, or the specific resistance we call. You can find out the units of rho. For units of rho, you can express rho as, what is the unit of R? Resistance, ohm into meter square upon meter. So this gives you ohm meter. This is the unit of resistance. So ohm meter is the unit of resistivity. So this is one more topic, small topic. Now if I say, since rho is E upon J and sigma is, if I talk about conductance or conductivity, this is 1 upon rho, or sigma is J upon E. So you get another formula, J equal to sigma E. This is another formula. Or in vectors you can write vector J equal to sigma dot vector E. This is the current density J written in terms of vectors. This is another interpretation. So you all have to remember this and you utilize in various questions. Now temperature dependence. If I talk about temperature dependence, these are small formulas, small relations which you will find in the numericals. So temperature dependence of resistance. If I say the resistance of a conductor at 0 degree Celsius is R0. Suppose the resistance at 0 degree Celsius is R0. Okay. Resistance at T degree, this is RT. So therefore, if I have to write RT, you can write RT equal to R0 into 1 plus alpha T. This is the formula which you have to remember. Or you can say RT equal to R0 plus R0 into alpha T. I'll tell you alpha equal to RT minus R0 upon R0T. This alpha is known as temperature coefficient of resistance and its unit is per degree Celsius. And for most of the metals you will see alpha is 1 upon 273 per degree Celsius. This is for most of the metals. So if I place this formula, suppose if I place the value of alpha in this, what we will get? RT equal to R0 1 plus 1 by 273 into T. This is RT equal to R0 into 273 plus T upon 273. That means RT equal to R0, you can say T dash upon T. That means, or you can say resistance is directly proportional to temperature. So this result tells us the resistance of a conductor increases with the increase in temperature. This is for conductors. Okay. So I hope you have understood this one. Now you will find color codes, carbon resistors. Carbon resistors you will find like this. These are carbon resistors. You must have seen in the electronic circuits, in the radio circuits or in television, the motherboard of a television. These are the 3 rings on the left side of this carbon resistor and there may be 1 ring on the right side. So first 2 rings gives first digit, first significant digit and second digit. First 2 rings from the left, they denote the first 2 digits and third one denotes the multiplier. And the fourth one shows tolerance. This is how do we identify this carbon resistor. So now how to read the value of the carbon resistor. So what will I do? I will tell you the table. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the digit. Now 0 stands for black color. This is for brown. This is for red. This is for orange. 3 is for orange. 4 is for yellow. 5 is for green. 6 is for blue. 7 is for violet. 8 is for grey. 9 is for white. And multiplier. This starts from 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. Like this it will go up to 10 to the power of 9. Okay. This is the color ring. Color ring. Digits. These rings, these colors will denote these digits, and the multiplier will be given by in terms of powers of 10. And tolerance, if I talk about, then tolerance is how to identify that fourth ring on the right side, that is for in the terms of gold color. So golden ring, for gold tolerance is plus minus 5%. For silver it is plus minus 10%. And if there is no color, then that means tolerance is plus minus 20%. These are the values, and how to remember these values. What will you do? You just see the abbreviation of these colors now. Then you will find the abbreviation BB Roy of Great Britain had a very good wife. This is the sentence which will tell you all the colors. Now you see BBROY, capital letters, then take G, then once again Britain B, this is V stands for violet, V, this is for grey, G, and this is for white. So black, brown, red, orange, yellow, green, blue, violet, grey, and white. This is how do we remember the codes. So students, I hope you have understood. Now how to find the value, I will tell you. Suppose you can draw here itself. Suppose the resistance is given as 57 into 10 to the power 5, this much ohms, plus minus 10%. So this is a 1 mark question. This value is given and he will ask you what are the colored rings present on the carbon resistor. So how will you identify? 5 stands for, the first digit 5 stands for green. That means the resistance, means the carbon resistor will be like this. The first one will be green. Second, 7 stands for violet. Then what is the multiplier? 10 to the power of 5. That stands for green once again. and this is 10%. So this will be a silver ring. So this is how you write the colors, and you can either get this question like this, or they will give you in exam, you will get the picture of this resistor and they will ask you what is the value of the resistance of this carbon resistor. So this is very easy. This consists of 1 mark question in the board exams. So students, I hope you have followed this. And now we have combination of resistors. Combination of resistors. First one, series. Suppose these are 3 resistors like this, connected to a battery or a cell. This is R1, R2, R3. This battery gives a potential V in this circuit. So this across this resistor, let the potential difference be V1, for this V2 and this V3. Okay, and the current is flowing like this, I. So since the resistors are connected in series, the current I will remain same through the resistors. Same current will flow. Okay, so potential difference across R1 is how much? V1 equal to I R1. Likewise for R2 R3, V2 equal to I R2, V3 equal to I R3. If I replace all these 3 resistors by a single resistor, no, and potential difference, this is V, and this, suppose this is R and this is of course I, the current is going. So this is the equivalent resistor R. If I replace all these 3 and put a single resistor which is working for these 3 alone, no? So for an equivalent resistor, we will get V equal to IR. Okay, but what is V? You see, V equal to V1 plus V2 plus V3. So IR equal to IR1 plus IR2 plus IR3. So IR1 plus R2 plus R3. So I cancels out and R equal to R1 plus R2 plus R3. This is the equivalent resistance of these 3 resistors which are connected in series. Students, this is for the series combination. I hope you have understood, followed. This is easy. And now you can find for parallel as well. For parallel combination, you take, this is one resistor, this is another one, this is another one, and you connect them with a cell like this. So this current I will go like this. This I will break, no? So I1, I2, I3 like this. It goes. This is resistor R1, this is R2, this is R3. Here once again you see, they all 3, I1, I2, I3, they will combine to form I once again. Okay, the circuit is giving a potential difference V. So since they are connected in parallel, each branch will have the same potential difference V. Okay, so what is the current which is going through this branch? First branch, current through R1. So this is I1 equal to V upon R. So V upon R1. So for R2, similarly for R3, this is I2 equal to V upon R2. I3 equal to V upon R3 like this. Now if I replace all 3 resistors by a single resistor, So what shall be the current through that? So for an equivalent resistor, I equal to V upon R. No? But what is I? I equal to I1 plus I2 plus I3. So V upon R equal to V upon R1 plus V upon R2 plus V upon R3. Or this V cancels out. You can say 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the equivalent resistance for the resistors which are connected in parallel. So students, you saw small topics, but they all are important. They will find their applications in the numericals, and you will find it easy to solve. This, of course, this you have studied in class 10th, certain things you have studied in class 10th, but here we have some enhanced things, enhanced topics in class 12th, and you will have a revision also, and you can enjoy solving numericals based on these topics and formulae. So in my next lecture I shall take some good and difficult numericals and tell you how to solve them. Okay, then see you.